Okay, last example in section P6. This is what we call a complex rational expression because it's a rational expression within a rational expression. Okay, so what I'm going to do is I'm going to break this into two pieces. I'm first going to look at simplifying the numerator, and we'll do this in blue, and then we're going to look at simplifying the denominator, and then eventually we'll put them all together. Okay, so let's look at this. How do I simplify this? How do I add x squared plus 1/3? Okay, well, to make this into one rational expression, remember that x squared, well, or anything really, you can always divide it by 1 and get the same expression. So what is the common denominator here? The common denominator is going to be 3. So I'm going to multiply the numerator and denominator both by 3. And so this is going to end up being 3x squared plus 3, or plus 1, sorry, that's a 1, divided by 3. Okay, great. Now let's look at this one. Well, in order to subtract these two, right, I need to find a common denominator. Well, what is the common denominator here? Or I can say least common denominator. Well, this one is going to be a y. This one, the common denominator needs to have a y in it. This one, it needs to have an x squared in it. So y, x squared, y, however you want to say it, this is going to be our least common denominator. So this first one, I need to multiply by the missing component, which is x squared. So I multiply by x squared to the numerator and denominator. Alright, and the second one, we have to multiply by the missing piece, which is y. Okay, so when I go through and do this, what do I get out as a result? I get 4x squared over x squared y minus 5y over x squared y. And now I write this all over one denominator, x squared y, and the numerator is just these two put together. So 4x squared minus, keep the sign in between, keep the operation in between, minus 5y. Okay. So I found these two. I found the common denominator for the numerator on top of the big bar, and I found the common denominator and simplified this rational expression below the big bar. So really what this is now saying is that this whole thing, this is equal to, and I'm going to write it a different way, 3x squared plus 1 over 3 divided by, because that's what this bar means, divided by, okay, divided by 4x squared minus 5y all over x squared y. Okay, in the last video we learned how to do this. So we keep the first one, we leave the first one alone, and then we change it to multiplication, or you can use a dot if you want, either one, by multiplication by the reciprocal. Okay, let me undo that just so we don't get confused. And I'm going to use a dot for multiplication. So multiplication by x squared y over 4x squared minus 5y. Okay, and this I can do. So multiply the numerators. Okay, so I have the quantity 3x squared y, or 3a, let's try that again, 3x squared plus 1, that quantity times x squared y, divided by 3, and then multiply that by the other denominator, so 4x squared minus 5y. Okay, and that's my answer. I can't, you could, normally you would try and simplify it if you can. In this case it's not going to work out too well. Okay, so let's kind of review what we did, just so we can kind of walk through that process again. So what did I do? I had a complex rational expression, meaning I had a rational expression within a larger rational expression. So what did I do? I broke it into pieces. I did the first rational expression I saw, which was contained in the numerator. I simplified that and got it into one rational expression. Okay. Then I looked at the other rational expression, which was in the denominator. What did I do? I simplified that, found a common denominator, multiplied by the missing pieces, and then simplified, got that down. Okay. Then really, if I have this bar, that represents division. Okay, so that's why this bar here represents division. So that's why I wrote it as the numerator, that rational expression, divided by the denominator, and whatever that rational expression simplified out to be. And so then I wrote it out, and then we discussed in the last video that division is really multiplication by the reciprocal. So I just changed it to the multiplication by the reciprocal and did the multiplication as normal to get my final result. Okay. Easiest thing with big expressions, break it into pieces that you know. Okay. And so that concludes section P6.